Video number 157 plus. Occam's razor. Hello. According to Wikipedia, Occam's razor is a principle of philosophical reasoning, falling within the concepts of rationalism and nominalism. The term comes from shave, which in philosophy means to eliminate unnecessary explanation of a phenomenon, and from the philosopher William of Ockham, 1285–1347. William of Ockham was an English philosopher, logician, and theologian, a member of the Franciscan order. His essentially rationalist doctrine was suspected of heresy because it criticized the possibility of demonstrating the existence of the divine. It is sometimes considered a prefiguration of modern science, English empirism, as well as analytical philosophy, because it emphases facts over metaphysical speculations. The original formulation of the principle by William of Ockham is multiplicities should not be introduced without necessity. Pluralitas ponenda sine necessitate, in a work published in 1319. The variant, entities should not be multiplied beyond necessity, is often attributed to William of Ockham, but it resembles a rather free interpretation, still very close to the original idea. Occam's razor does not provide a clear criterion for distinguishing between two explanations of the same phenomenon. It is only the case where two hypotheses have the same likelihood that the simplest or most parsimonious hypothesis will be favored. And the notion of the simplest hypothesis is far from being impartial. We can see, therefore, that the principle of parsimony, which is very often invoked in physics today, represents a dangerous generalization of the precise statement described by Occam, which was a matter of common sense in its original formulation. The application or non-application of Occam's razor can lead to errors and hinder research by favoring the status quo of existing theories over bold ideas that require thinking outside the box. Let us see some examples. 1. In mathematics, irrational numbers were ignored by the Greeks, whereas they turned out to be indispensable for the construction of infinitesimal calculus. 2. In mechanics, if we had been content to seek to understand what happens on Earth, the fundamental notions of force, acceleration, and inertia would probably never have been developed, and the idea of universal gravitation was a challenge to Occam's razor. 3. Rejection of elliptical orbits, Kepler's laws. Even after Copernicus's heliocentric model, Johannes Kepler's ellipses were resisted, including by Galileo, because circles were viewed as geometrically simpler and more perfect. Adding elliptical eccentricity felt like a necessary complication compared to circular orbits with adjustments. 4. Rejection of atomic and molecular theory. Late 19th, early 20th century. Ernst Mach and other positivists and phenomenalists dismissed atoms and molecules as unnecessary metaphysical entities because they were too small to observe directly. A simpler ontology, no invisible particles, seemed preferable, but this delayed acceptance of kinetic theory and statistical mechanics until overwhelming evidence, e.g. Brownian motion, explained by Einstein in 1905, for the issue. 5. Max Planck's initial reluctance toward quantum theory, 1900 onward. Planck himself viewed energy quanta as a desperate and unnecessary assumption to solve the ultraviolet catastrophe in black body radiation. He treated it as merely a mathematical trick rather than physical reality, partly because it violated classical continuity seen as simpler. This hesitation reflected a broader resistance to adding discrete entities when continuous classical physics appeared more parsimonious. 6. Delayed acceptance of continental drifts and plate tectonics. 1910s, 1960s. Alfred Wigner's idea was often rejected as overly contrived or ad hoc, requiring new mechanisms like mental convection without direct evidence at the time. Critics favored simpler explanations, fixed continents, land bridges for biogeography, over what seemed like unnecessary geological complexity. The theory only gained traction with the seafloor spreading and paleomagnetic data in the 1960s. 7. In biology, the principle of non-hereditary transmission of acquired traits, in opposition to the politically oriented doctrine of Lysenko, could have led us, out of a desire for simplification, to ignore all of epigenetics and its transgenerational aspect. 8. Resistance to Helicobacter pylori as cause of ulcers, 1980s, 1990s. Barry Marshall and Robert Bean Warren's bacterial hypothesis was initially dismissed because it challenged the established view, stress and acid as primary causes, and seemed implausible. How could bacteria survive stomach acid? Simpler physiological explanations were favored until decisive evidence, including Marshall's self-experiments, overturned the status quo. Since then, many acidophilic germs have been discovered. 9. Radical behaviorism in psychology, mid-20th century. Figures like B.F. Skinner insisted mental states and internal processes were superfluous assumptions. Behavior could be explained solely via observable stimuli and responses, seen as simpler. This Occam's chainsaw approach delayed cognitive psychology until evidence for internal representation became undeniable. 10. In medicine, over-application of horses not zebras, the diagnosis heuristic was against rare conditions, but rigid use had led to misdiagnoses by ignoring complex or uncommon causes when symptoms don't fit the simplest pattern. 11. More recently, I showed regarding the Hogg object, video number 145 plus, how a partisan concession of simplicity can lead to favor the most mathematically improbable solution. Here are finally a few examples of the opposite situation where we refrained from applying Occam's razor to theories that still await credible confirmation based on the nature of the vacuum and matter. 1. The relativistic law of velocity composition, which is neither commutative nor even associative in the vector framework, based on the decreed invariance of the speed of light in a vacuum. Is it really simple? 2. The notion of superimposed states, of which we know that no experiment will ever prove the material reality. Is it really the simplest way to model the behavior of matter at small scale? The worst part might be the application of the principle of parsimony to exclude the existence of multiple universes and deduce the existence of the supreme watchmaker, as if one could only imagine these two alternatives. As a conclusion, today's physicists invoke Occam's razor a bit too much to avoid questioning what we think we know, whereas in many cases, nature has repeatedly required adding complexity to entities, forces, or dimensions, despite classical views appearing simpler. Critics note that Occam's razor is misleading when opposed dogmatically to innovative ideas that initially seem elaborate. The principle remains useful, but only when simplicity is carefully defined. And we must avoid that this philosophical doctrine, originally based on common sense to fight obscurantism, be diverted from its purpose to promote our present fashionable scientific ideologies against innovation.